Let us now discuss the 6 major classes of enzymes, which are based on the types of reaction they catalyze. The first major class of enzymes are oxidoreductases. Oxidoreductase catalyzes an oxidation and reduction reaction. Since oxidation and reductions are linked processes, oxidoreductases requires coenzymes that is oxidized or reduced as the substrate is being reduced or oxidized. The 3 subclasses of oxidoreductase includes oxidase, reductase, and dehydrogenase. Before we proceed with the example listed below, let us first differentiate organic oxidation reaction to organic reduction reaction. An organic oxidation reaction is an oxidation that increases the number of carbon-oxygen bonds and decreases the number of carbon-hydrogen bonds. While an organic reduction reaction is a reduction that decreases now the number of carbon-oxygen bonds while it increases the number of carbon-hydrogen bonds. So what is now the relationship of carbon-oxygen and carbon-hydrogen bonds with regards to oxidation and reduction reaction? Take note that during oxidation and reduction reaction, the number of carbon and oxygen bonds is inversely proportional with the number of carbon-hydrogen bonds, meaning if the number of carbon and oxygen bonds increases, the number of the carbon-hydrogen bonds decreases, and vice versa. The substrate in this catalytic reaction listed below is lactate, while the enzyme that catalyzes this reaction is lactate dehydrogenase. From this reaction, the lactate dehydrogenase removes 2 hydrogen atoms and transferring the bonds to the formation of pyruvate, forming a carbon double bonded with oxygen. The next class is transferase. From its name, its major function is to transfer a functional group from one molecule to another. There are 2 major subtypes of transferases. There are transaminases and kinases. Transaminase catalyzes the transfer of amino group from one molecule to another. So what now are kinases? Nope, that is not the word you say when you are annoyed. Kinase. Kidding aside, kinases catalyze the transfer of a phosphate group from adenosine triphosphate or ATP to give adenosine diphosphate ADP and a phosphorylated product, a product containing an additional phosphate group. As you can see in the illustration below, the substrate is glucose while the enzyme is hexokinase. Its action is to transport or transfer the phosphate group from the ATP to one of the carbon rings of the glucose 6-phosphate. So your ATP now is being reduced to ADP. The next class of enzyme is hydrolase. Hydrolase is an enzyme that catalyzes a hydrolysis reaction in which the addition of water molecule to a bond causes the bond to break. With the example below, maltose being the substrate for this reaction, wherein maltase, the enzyme acts upon it, causes the hydrolysis between the glycosidic linkages, breaking down it into 2 glucose molecules. The next class is lyase. So what is lyase? No, it is not the word you say when you want someone to go away. Lyase is an enzyme that catalyzes the addition of a group to a double bond or removal of a group to form a double bond in a manner that does not involve hydrolysis or oxidation. In the example below, you can see the fumarase, an enzyme that is an example of a dehydratase, causes the addition of components to water to a double bond. The next class are isomerases. An isomerase is an enzyme that catalyzes the isomerization or the rearrangement of atoms of substrate in a reaction, converting it into a molecule isomeric with itself. Take note that there is only one reactant and one product in reactions where isomerases are operative. The last class are the ligases. A ligase is an enzyme that catalyzes the bonding together of two molecules into one with the participation of ATP. Again, the six major classes of enzymes are oxidoreductases, transferases, hydrolases, lyases, isomerases, and ligases.